Okay, good morning students. So today we will be going to discuss more about chapter 12, that is electricity and circuits. So yes, in our previous class we discussed about different types of we discussed about electricity. Okay, then we talked about source of electricity, means how do we generate electricity. So for that, for generating electricity, we must need a power plant. So we have three power plants basically. Okay, so hydroelectric power plant, hydroelectricity power plant. Second one was thermal power plant, thermal power plant, and the fourth one was nuclear power plant, or you can say atomic power plant. Atomic power plant. Okay, then we discuss about the cell. Okay, the dry cell, the battery. So today we are going to discuss about solar cell. So what do you mean by solar cell? So as we know, what do you mean by solar? Solar means sun, or you can say sunlight. That means the things mostly related to sun or the sunlight is known as solar, or you can say solar energy or solar cell whatsoever. Okay, so what do you mean by solar cell, and where do we use it? Okay, actually solar cell is the device which directly converts solar energy into electrical energy. Solar energy into electrical energy. What do you mean by this? As in the case, as we discuss about a hydroelectric power plant, okay, in that case mechanical energy is converted into electrical energy. I told that a certain round object, okay, you can say the pulley or whatsoever, when that is run at a certain speed, that means revolution per minute, that means it is mechanical in nature, and that energy is converted into electrical energy in that case, in hydroelectric case. Similarly, in atomic, chemical energy is converted into electrical energy. Okay, but in case of solar cell, solar energy is converted into electrical energy. Okay, so as we know, the ultimate source of heat and light is the sun. Okay, plants prepare their food with the help of the sun only. Okay, in the process of photosynthesis, then we get energy and the warmth due to the sun only, that means solar energy. So in solar cell, solar energy is converted into electrical energy, and that electrical energy we can use it. Okay, so solar cell are used in mostly wristwatches, then in calculators we can see there is an option of battery also, means dry cell in calculator. But apart from that, we have a thin panel, a thin plate. Okay, thin plate, and that is for solar, that is known as solar panel. And if battery is not working or the battery cell dries up, okay, so alternative we can put that calculator in the sun or the lights. It's not that you have to put it in the sun only. The lights can convert, solar light can convert it into electrical energy, and the calculator works in that condition. So solar panel are used for producing electricity. So there are different solar panels. Okay, as we can see, this is solar panel. It's almost you can say square in shape or rectangular in shape. Okay, and here what happens, it is mostly placed in roofs, okay, or where direct sunlight falls, and in place where there is no stored energy or stored electrical energy. Okay, where there is no stored electric energy, these solar energy panels are used. As for example, we don't have energy or power plant in this space. Okay, so solar energy is used mostly in space. That means who use in a spacecraft, you can say in spacecraft or space station. Okay, you can say space station or artificial satellite. Space station and artificial satellites, because to function this space station, either that is needed, the fuel is needed, but in space station various research has to be done for more than a month or a year. Okay, so in that case, if they are out of fuel, what will happen? That means the engine will not work and they may die in the space only. So what they do, they use the solar panel so that they can use the natural source for electricity, okay, or to generate electricity. So these are the major use of solar energy or solar panel, okay, space station and artificial satellites. Then we have, apart from this, nowadays as we know that solar energy or electricity is very much limited. Okay, that means as for growing population, we are consuming more electricity. Okay, so solar energy, solar panel are also used in also used for or used in household purposes, then street lights. Okay, then we can say at various places, okay, other places also, and it is more conventional because the solar panel, when it is heated up, okay, the energy is stored. Okay, the energy is either stored or it is processed through the battery, okay, a bigger battery, and from battery direct current is passed. Okay, so for small appliances like lighting a bulb, okay, even we have solar cooker also nowadays, that is very much effective. Okay, so this was all about solar cell or solar panel, or you can say solar energy. Now we will move towards another components of electricity or electric circuit, that is the electric bulb, or we can say torch bulbs. So it is the component of electricity. Okay, that means it is one of the major part of electricity. Now in this case, first of all, we will learn about what it constitutes. What it constitutes. Okay, what it constitutes means what is present in the bulb. So a bulb is, as we all know, a bulb is a shape, okay, in which the glow-on part, okay, is made up of glass. Okay, then we have a filament here, a thin filament, 2 or 3 filament can be there, and there is a groove like structure, or you can simply mark like this also. Okay, bulb, and a point end here, point end here. Okay, and there is a structure here. Okay, so you can just imagine that this is a simple bulb. Okay, so this bulb has a wire like structure. One end is here, that means the one end of the battery terminal, the wire is connected one at here and another wire will be connected at here. Okay, as for example, I'll make a simple electric circuit. Okay, suppose this is a battery. Okay, we have a bulging end and we have a positive terminal here and we have a negative terminal here. So to make a circuit, simple circuit, what we have to do, we have to connect a wire. This is a wire. Okay, so one terminal of the wire is connected to the one end of the bulb and another terminal of the wire will be connected to the other end. Okay, or you can say that we can put a switch here. We can put a switch here. This portion is switch. So when the switch is attached, okay, when it is attached, then the bulb will glow. The bulb will glow. But if the switch is again removed, then the bulb will not glow. Okay, the bulb will not glow. And for that, what we have, we will discuss about switches and batteries we have discussed. Okay, wire as we all know. So in this only we will discuss more about lightning bulbs. Okay, so suppose say that this is a example of a circuit diagram, we can say circuit diagram. So circuit diagram, we have two types of circuit in case of circuit diagram. Two types of circuits are, number one, open circuit, and number two, closed circuit. Okay, so let's talk about open circuit and closed circuit here. So in open circuit, all the components are not connected. Components of electric current are not connected. Or we can see, not all the component, the switch is not connected. Okay, if the switch is not connected, the bulb will not glow, and that type of circuit is known as open circuit because it is opened here. Okay, not only here, if suppose say that if this circuit is closed, suppose there is a switch is on but still bulb is not glowing, so there might be a problem in either in the battery cell or in the wire or in the bulb. Okay, so if there is a defect in a bulb or in a wire or in a battery, okay, then the bulb will also not glow. That means any of the components, okay, we can say any of the components of an electrode is not connected. Okay, so in this case we will say that the circuit is open and bulb will not glow. Okay, you can say here this is open circuit. Suppose this is here open, or if we have a defect in battery also, that also we can consider it as an open circuit. Or if there is a defect in the wire, again we can consider it as a open circuit. Then if there is a defect in bulb also, it can be defect in the bulb, battery or wire. Okay, then we can say that it is a open circuit. So now let's talk about closed circuit. So in a closed circuit, all the components of an electric current and electric circuit are closed, are connected, you can say. As for example, in this case, okay, suppose when we put on this switch, so there is no breakage, okay, there is no breakage of electric current. So with the battery, the electric current flows through the wire in one terminal and from the another terminal to the another terminal, and the bulb will glow because this will be heated up, the filament will be heated up and the bulb will glow. Okay, and this type of circuit is known as closed circuit. Okay, so this was all about open circuit and closed circuit. Okay, so as we talked that in this discussion we talked about different components, that is electric battery or dry cell, we talked about bulbs, okay, components of bulbs, then we talked about open circuit and closed circuit and the reason that bulb will not glow. If the switch is all connected, but if the bulb is not glow, so there must be a defect in either bulb or wire or in a battery cell. Okay, so this was all about electric circuits. Now we will talk about another topic, that is symbol of electric components. So we discuss about all the components, okay, and it's not possible for us to draw a battery or any of the components. So basically we have how many type of components? Number one, bulb. So bulb is one of the most important components or major components, we can say. Then we have cell or battery. Number three, wires. Okay, you can add wires, connecting wires. Okay, then we have switch. So these are the components. Now what are the symbols? So symbol of a bulb, okay, we can put like this. This is the symbol of the bulb, okay, and if it is glowing we can put like this, or if it is not glowing we can simply make like a heart, okay, or we can do like this also because it is connected. Okay, then we have a cell or battery, either one cell, then we have the smaller one, okay, the larger one act as a positive terminal and the smaller one act as a negative terminal, okay, if there is a single cell. But if we have more than one cell, so it will be like this. Okay, got it? So it will be like this. Then we have wires. Wires we can put like this, the symbol of wire in a straight, or we can just coil it. Okay, then we have, if the switch, okay, switch we can make like this. This is the switch which is broken, but if it is connected we can put like this, or we can put directly okay, this is connected, this is not connected because it is not touching the end is not touching the both, and this is connected. So we can put symbols like this. So bulb, we have a symbol of blown bulb and a bulb that is not blown. That means we can say that the bulb of a open circuit and a closed circuit. Then we have a symbol of cell, a battery, one cell, single cell, okay. Then wire, a straight line or a coiled. We can make switch. For open circuit we can make switch like this, and for closed circuit we can make switch like this. So this was all about symbols and electric components. And a circuit diagram, as we discussed already,